63. The median of that test, the median is always Q2, second quartile. The median is 73. The third quartile, which is Q3, the 75th percentile of that test was 88, 86. And the maximum number in that test, maximum number in that test was 94. So 94% was the highest grade. All right, so you have to know that whenever you are given a 5-number summary, you have to know that the smallest number is the minimum number, the second to the smallest. So the question here is, use this information to draw a box plot of the exam score. So he wants you to draw a box plot of the exam score. So let's do that. So draw a box plot, represent this grade in a box plot. So we're going to draw a normal box plot. And this is a sketch. So the minimum number is at the leftmost whiskers. So minimum number is right here. And that number is given to us as 56. The first quartile, which is Q1, is 63. And the second quartile, which is Q2, is 73. The third quartile of the test, the third quartile is 86. And the maximum number of that test is 94. So here is our box plot. As the box plot we are told to draw. We are told to represent the 5-number summary in a box plot. So this is a box plot of Professor Dang's grade. I am going to put a line here, so. And we can actually check if there is something like skewness or outlier in that test. So if we subtract 63, if we subtract 63, 56 plus 63, we will get the distance from first quartile to the minimum number. Okay, so, but there are other things they can also ask us here. He could actually ask us what is the interquartile range. So suppose we are told to find the IQR. The IQR is always the third quartile minus the first quartile. Hope you still remember that from Unit 1. That's why we are reviewing for final exam, because final exam starts from Unit 1. So the third quartile starts from Q3 minus Q1. So let's see what it is. So Q3 minus Q1, that's 86 minus 63. So the interquartile range is 23. So the interquartile range is 23. So that is the interquartile range, IQR. The distance from the third quartile to the first quartile is the interquartile range. Okay. The next thing could be, let's see if there's another question there. So we found the interquartile range, and remember that the first quartile is the 25th percent, the first 25. The person who scored 63 did better than 63% of the students that took the test. The second quartile, which is median, is 73%. That means the person who scored 73 did better than 50% of the class. Let's repeat Q1. Q1 is the first quartile. The person who scored 63 did better than 25% of the class. The person who scored 73, which is the 50th percentile, did better than 50% of the class. The third quartile, which is 86%, the person who scored 86% did better than 75% of the class. So that's how we interpret quartile. So that is the question on Professor Dung's first test. So he collected the exam script and did this descriptive statistics and the 5-number summary. And he told us to draw a box plot and represent his 5-number summary in a box plot, and we just did. We also found the interquartile range. We can also be told to find the range. So the range is always maximum minus minimum. So what is the range of his grades? It is maximum minus minimum, which is 94 minus 56, maximum minus minimum. So we're going to find the maximum minus minimum, 56, 94 minus 56. 94 minus 56. So we got 14 there. 14 minus 6 is 8. 8 minus 5 is 3. So we have 38. Therefore, the range is 38. The range is 38. The interquartile range is 23. I hope you remember that the range is not the same as the interquartile range. Okay, so we have answered the question about Professor Dung's test, first test. So that is number 1 question in that Unit 1 practice test. So let's go to, so that's the question. Then if you look at the diagram and you are not liking what you're seeing, please draw your own box plot. Make sure you place everything where they're supposed to be. And by the way, in your tests, you will be asked to find the interquartile range. You will also be told to find the range. So to make sure you know. Okay, number 2 says fill in the blank. Divide something or dash divides data into fourths. What is that? What is that divides data into fourths? Is it the quartiles? Is it the outlier? Is it the range? Is it the z-score? Well, let's find out. Let's find out. We already just did the interquartile range, and we used the let's go. So we use the box plot to do that interquartile range. So this is this one we are looking for. And you notice that the quartiles, the three quartiles, divide divide any data into fourths. So from here, from Q1 to the minimum is 1. From Q2 to Q1 is 2. From Q3 to Q2 is 4. From maximum to minimum is from maximum to Q3 is 4. Therefore, your answer to that question number 2 is the quartiles. The quartiles divide any data into 4. It may not be, yeah, into 4. The quartiles. So it's always good to use a box plot to answer question number 2 in that practice test. So your answer here should be the quartiles divide the data, any data set. The quartiles divide any data set into fourths. So like I just showed in the, okay, so the next question says dash is obtained by dividing the population into homogeneous groups and randomly selecting the group. So that is a kind of a sampling method, dividing the population into homogeneous groups and randomly selecting individuals from each group. So which one is it? Is it systematic sampling method? No, cannot be systematic sampling method. Stratified sample, yes, it is stratified sampling method. Okay, so you divide them and then you keep select randomly data from the group. Well, sometimes stratified sampling method and cluster sampling method are different. They look the same. But in cluster sampling method, remember that they are all, the population is already in clusters. So for example, if I am doing a collection of samples and I go to Simpsonville and collect 10 people and come to Greenville, actually Malden, correct sample, and so on, and I collect it from 5 different sets or 6. The important thing is that this Malden City was already there. I wasn't the person that divided it. Simpsonville was already there. So they're already in clusters. So I made it, I went to each cluster and got a sample. But stratified sampling method is when I do the dividing by myself. So if I do the dividing by myself, then it's stratified. And then I can, even though I do the stratified sampling, that's I put them in strata, I can still do a simple random sample from the small sample that I get. So SRS must always be used. You can use it in combination with any sampling method. All right. Okay, so let's keep on going with this. Okay. Well, let's see question number 3, or is that 4? In a national survey of high school students, grades 9 to 12, 25% of the students who responded to a survey reported that someone had offered, sold, and given them an illegal drug on school property. All right. So 25% said that, and the school property is the value, a parameter, or a statistic. So this question said in a national survey. So it is the whole American survey of high schools, and they are students from 9 to 12. 25% of the students who responded. So 25% of the students is a parameter because we are doing the whole United States. It's a parameter. 25% reported that someone had offered or sold or given them an illegal drug on a school property. Is the value a parameter? It's a parameter. It's a parameter because it's taken from the population. The next thing is going to be when we get to inference, to prove this true or false. So we will take a sample and use the sample, take many samples from many schools and use this sample to find the mean of the sample and use that to test this claim, because this is a claim that needs to be tested to be either proved right or wrong, because sometimes people make a hypothetical claim. We call it a hypothesis. Somebody needs to agree, either say that this percentage is too high or this percentage is too low, and collect maybe samples of 50 different 50 simple random samples from different schools in America, and ask them, has anybody ever given you or sold or given you an illegal drug in the school? And when somebody surveys and collects the sample, we can use that to test a hypothesis on this claim. This is a claim that needs to be either proved right or proved wrong with a level of significance. Before we start, we can maybe use a level of significance of 5%. So anyway, the important thing is that that is a population, and therefore it is a parameter. Determine whether the variable is qualitative or quantitative. Remember, the reason why we are starting from unit 1 is because final exam is cumulative. So we started from unit 1. I just want to let you know that we have been actually doing unit 4 for some time now. So that's why we went to unit 1. But one thing you need to know is final exam is cumulative, starts from unit 1 to unit 4. Everybody must take final exam. Even if you're making an A, averaging an A, you still have to take final exam. I sent you an announcement. Final exam is a standalone grade, and it's going to replace your lowest test grade. So you might want to take it. If not, then you get a 0 for the standalone grade, and you will not have any grade to replace something. All right, so we're not going to follow this step by step anyway. So let's go to do some more. We can also get, one thing we need to do is find the sample variance and standard deviation. So here we are given a sample size, but how do we know it's a sample? We are told that it's a sample. Find the sample variance. So it's a sample. You better be careful. You have to be watching. Make sure you read the question, because if it says it's a population, then it's a population. But now we are already told it's a sample. Find the sample variance and standard deviation. So all you want to do, you can do it by hand, but no one says you must do it by hand. So if you can do it with calculator, it's easier. So you pop those numbers in your calculator. Remember that the test is also about speed and accuracy. You're allowed to use your calculator. You're being tested on speed and accuracy. The use of calculator is also being tested. Your knowledge of how to use your calculator. So if you cannot use your calculator, then you may not even finish the final exam. Okay, by the way, let's go to start, edit, and put this data in a L1, and the data is 25. There is a raw data. Actually, 23 is the first one. Enter. The second one is 15. The third one is 5. The fourth one is 10. And the last one is 8. So sample size is actually 5. Sample size is 5. Remember, I cannot say it enough. When you finish putting data in a list, you eyeball the data. Make sure that you put in what you are given. People make mistakes. You don't want to put in what's anything extra. That is a no-no, because really you have already failed the question if you put in, if your data is wrong. Okay, so the next one is do a one variable stat of this data. This is a raw data. And you're not told to find the mode, the mean, the median, so you do not have to worry about sorting it in ascending order. You're only told to find the variance and standard deviation. So we go straight to start, arrow to calc, do one variable stat of this data in L1. It's a raw data, so it's a one variable stat of L1. And so I do not need a frequency list. No frequency list because it's a raw data. So I'm going to calculate. And so the mean, they didn't ask me about the mean. So I shouldn't worry about the mean, but they asked me about standard deviation. Remember, it is a sample, so you are going to be collecting the sample standard deviation, not population standard deviation. So the sample standard deviation to 3 decimal places is 7.05, approximately 7.05. So we come over here and put in 7.05. Remember, I'm talking about sample standard deviation. So right here, you put in 7.05. 7.05. 7.05. Okay. And then if I'm told to find the sample variance, which I'm told to do, then I showed you the quickest way to do this. So you go to second verse. Let's go to verse statistics. Go to verse statistics number 5 and look for sample variance. Sample variance is number 3, and actually square it, because if you want to find the variance, you square the standard deviation. Okay, so the variance is 49.7. So sample variance is 49.7. You come over here and write 49. Remember, you got to be careful. You are asked to find the sample variance. So you come over here and put 49.7. 49.7. Okay. And what else? That's all. This question is very easy. This kind of question will be in your test. The important thing is that you remember what to do. Remember what to do. Okay. Question number 13 says, determine whether the quantitative variable is discrete or continuous. So a quantitative variable can be discrete or continuous. So it's asking you the weight of a child. And by the way, I hope you know what discrete means. Discrete is countable. Discrete means cannot contain decimal, while continuous means can contain decimal. Measurable. Measurable can contain decimal. This cannot contain decimal. The question is, if I measure the weight of a child, can I have 60.5 or maybe 30.7? Yes, I can. the weight of a child can contain decimals, so it's not countable. Therefore, it's very simple. It's a very simple question, but people forget. Okay, so the variable is discrete. No, it's continuous. The variable is continuous because it is not. The variable is continuous because it's what it's talking about here. The variable is continuous because it is not countable. Well, the best possible answer is C. And if you think that that doesn't represent what you want to say, you can add your explanation. Whenever you add your explanation, it shows that you know, you understand the question very well. So if you add your explanation in an exam, that actually tells more that you know what you're talking about. So let's look at the diagram. The diagram on the right-hand side. For the histogram on the right, determine whether the mean is greater than, less than, or approximately equal to the median. Another way of asking you, is it skewed left? Is it skewed right? Or is it approximately normal? So what we need to do, we are given this kind of question, we try to superimpose a density curve on this. If I try to superimpose the density curve on this, it can, let's see how, if my hand is going to, well, it is, let me pull my, if I try to superimpose the density curve on this, the density curve can just look like, my density curve will look normal. So that is the kind of histogram that I had. It's approximately normal, it's not exactly normal. So I can actually say that the mean, that mean for the histogram on the right, determine is greater than or approximately equal to the median. So because I histogram, it looks like it is approximately normal, then I'll say that the mean is equal to the median, approximately normal. So the mean is equal to the median. If a data is approximately normal, the mean is equal to the median. Well, we say approximately. I can say mu is equal to the median. Let's call median Q2. So whenever a data is approximately normal, the mean is equal to the median. So we call this one approximately normal. Approximately normal. Normal. When the data is skewed right, if a data is skewed right, we say that the mean is greater than the median. Well, so this is a diagram of a skewed right distribution. So in any skewed right distribution, there is an outlier that is on the right-hand side. So in a skewed right distribution, the mean is greater than the median. So this is skewed right. Skewed right. Okay. Well, in a skewed left distribution, the mean is less than the median. It means there's an outlier at the tail that is drawing the mean to the tail. So in a skewed left distribution, the median is greater than the mean. Skewed left. So in a skewed left distribution, the median is greater than the mean. In a skewed right distribution, the mean is greater than the median. In data that is approximately normal, the mean is equal to the median. So that's how you are going to explain what happens to the density curves. There are so many kinds of density curves, but we are only interested in approximately normal distribution, skewed left distribution, and skewed right distributions. Okay, so we talked about skewed left, skewed right, approximately normal, because they asked us a question. Sometimes in an exam, somebody asks you a question that will touch everything you have done to see if you understood. Is there any part of the test they want to see if you understand? They can ask you a question that it will cover almost everything you know. All right, so the following data, remember we are studying Unit 1 practice test, but you can see how Unit 1, which is descriptive statistics, actually points towards inferential statistics. But okay, so the following data represent the amount of time in minutes a random sample of 8 students exam. Let's see what kind of exam it is. Okay, 8 students took to complete the online portion of an exam. So there are two parts of that exam. One is online, one is face-to-face. So compute the mean, median, and mode. You already know how to do this. You put this data in your calculator and find the one variable start, compute the mean, told to find the mean, find the median, and the mode. Okay, so if you're told to find the mode, it means they're asking you if there's a number that occurs most. Is there any repetition? If there's asking you the mean, what is the number in the middle, and so on. So compute the mean, exam time, select that, compute the median. So you will put the data in L1 or L2. You just did what we do what you just did. I don't think we need to be doing that. Okay, find the population variance. So this question is just like the one we did before, but the difference is that you're told to find the population variance. So you got to be careful because you are told that this question is population. And since you're told it's population, you might want to, when you finish calculation, you are looking for population variance, not sample, not this one. Be careful, told to find the population variance. And you're also told to find the population standard deviation, not sample standard deviation. Even if your answer is wrong, even if your answer is right, but you mistakenly wrote your answer as a sample standard deviation, you failed it. And the computer is grading your paper. Computer doesn't know who you are. You just need to know the difference between a parameter and a statistic. And so when you finish your calculation, you know when it's time to collect the population variance. And when you have population standard deviation, you square it to get population variance. That's what you want to do. Okay. Benjamin owns, okay, I think we need to get out of here and do some, let's do some, we want to do some z-score, okay. Yeah, because z-score will surely be in your test. So let's pull this down and look for a question on normal distribution. All right, so you still remember this question from Unit 1. So this, you are going to be asked to use the empirical rule. So somebody wants to know in every test, In every final exam or test, somebody wants to know if you know how to use the empirical rule. Do you know how to use Z-score? Do you know what a standard normal distribution is? Do you know what any other distribution is? Can you find the area under the normal curve? So this is descriptive statistics. So somebody wants to know if you actually know what you are doing. So quickly, let's put this question in. Let's try to answer this question. So I'm going to do some cleaning right here before we answer the question. Yeah, we have to take one real world question and then. All right, so this says draw a normal curve and fill in the values for plus or minus 1 standard deviation, plus or minus 2, and so on. So it says a dog's lifespan. The lifespan of a dog is normally distributed with a mean of 12.5 and a standard deviation of 2 years. Estimate the probability that a dog's lifespan is between 10.5 and 14.5. Okay, so we are given the information, but we are also told to draw two kinds of normal curve. So the first kind of normal curve is with the raw score. So normal curve with a raw score, the mean is 12.5. And then I want to put in one standard deviation above the mean. The standard deviation is 2, so 14.5 is one standard deviation above the mean. 2 standard deviations above the mean is 16.2. 3 standard deviations above the mean is 18.2, actually 0.5. 18.5. Okay, so then the next one on the left hand side, I'm told to put in one standard deviation below the mean. So that is going to be 10.5. And 2 standard deviations below the mean, 8.5. 3 standard deviations below the mean, 6.5. I am also told to draw a standardized normal curve. So I am going to, and then the center is the mean. So the mean, well, let's make sure we remember. According to Z-score, we know that the mean Z is equal to the raw score mean 12.5 minus 12.5 over standard deviation. So numerator 12.5 minus 12.5 divided by 2 is 0. So the mean is always 0 in a standard normal curve. If I standardize 14.5, I will have 1, and then 16.5 will be 2, 18.5 will be 3. If I standardize 8.5, I have negative 1, so this is negative 1, negative 2, negative 3. So I can actually answer the question. The question they told me to answer is estimate the probability that a dog's lifespan is between 10.5 and 14.5. So the probability that a dog's lifespan lies between this 10.5 and 14.5 from here to here. So I'm going to shade this region. But according to empirical rule, the area under the normal curve between plus or minus 1 standard deviation is 68%. So according to empirical rule, this area I'm told to find is 68%. So 68% of the data lie under 1 standard deviation, plus or minus. Also, if I'm told to shade it here, 68% of the data lie within the shaded region. So that's what I'm told to find. 68% of the data according to empirical rule. So we have answered this question. Answer this question. So you better know your empirical rule. Make sure you can apply it in the test, the oncoming test. All right. So I think we're actually going to stop here because a few minutes to go. If anyone has any question, you can ask, but you want to review with the author's videos and the session videos in Blackboard. So you try to do your review even when you are on spring break. Try to review not spring break, I'm sorry, Thanksgiving break. Because as soon as we come back from Thanksgiving, you will start your final exam. There will be no other day. This is the only day for final exam review. But I wish you a safe journey if you're traveling for Thanksgiving. I hope you enjoy your family. I hope you enjoy yourself, celebrate your family. I am happy for you too. I celebrate you. You have a great Thanksgiving break. All right.